Hello and greetings to all who have joined us today for our yearly webinar, What's New webinar series, as we normally do in December or November of every year. We do the What's New webinar series, and we open it to everybody who are in our database. Thank you for taking your time out of your busy schedule to join us. Today's webinar's title is What's New in VisualCAD CAM and RhinoCAM 2019. VisualCAD CAM and RhinoCAM 2019 are slated to be released in December, sometime in December. We're hoping early December, first or second week in December. So today's webinar is going to give you a peek into what's new and what we've been working on for the product in about a year or so. And so what are the new enhancements and some of the new features in these products. My name is Joe Anand, and I'm the product manager here at MecSoft. With me today is Uday Honalagare, our support manager. He will be doing the demo and showing you all the different parts, the new features and the new enhancements that we have put in. And I'll be hanging out in the back listening and monitoring to your questions and answering them and whenever necessary, and maybe stopping Uday if there's something that I feel that is important to be shown. Before we get started, some of the housekeeping tips here. This webinar is being recorded, and it will be made available as usual to everybody who have registered for this webinar. And then we typically reserve the last 10 minutes for questions. I mean, this is apart from all the interactive questions that we would like you to ask. If you have a question, just go to the chat window, like this little picture shows. That's your chat window there, and just type in your question. And then we'll make sure that it gets answered. And if you don't have time to answer it, we'll make sure it gets answered by email later on. And so, as far as the webinar title and topics, as I already mentioned, today's topic title is What's New in VisualCAD CAM and RhinoCAM 2019. What we're going to be covering today, initially the first area that we're going to be looking at is VisualCAD enhancements. And then CAM enhancements would be next, and we'll be looking at both the VisualCAM as well as the RhinoCAM products. We'll be talking about the configuration changes that have gone in, some of the usability enhancements, and most important, the machining methods enhancements, what has gone into some of our machining algorithms and the options and the parameters. Also simulation, toolpath simulation and material removal simulation enhancements, some important ones there as well. And also post-processor enhancements, quite a few changes there as well. And then we also spent a lot of time on Nest module, based on a lot of your requests, and Uday is going to be showing you those enhancements as well. So Uday, go ahead and take it away. Thank you.
Thank you, Joe. Hello, everyone, and thank you for joining us today for our What's New webinar in VisualCAD CAM and RhinoCAM 2019. And as Joe pointed out, we'll be starting out with the CAD enhancements first in our standalone product, VisualCAD CAM, and then we'll take a look at the CAM enhancements both in VisualCAD CAM and RhinoCAM. And as we go through this webinar, if you do have any questions, please feel free to post those questions in the questions panel, and we'll be more than happy to get those questions answered for you. So we have a What's New document that's available out there, and you'll be receiving a link for viewing the document. So the What's New document lists all the enhancements and new features that have been introduced in VisualCAD CAM 2019 as well as in RhinoCAM 2019. First, we will be covering the enhancements in VisualCAD 2019, and I will be showing some of the enhancements as we go through the webinar presentation today. So there's been several improvements to VisualCAD CAM 2019, and some of the enhancements in VisualCAD are as follows here. So one of the very nice enhancements we could think of here is being able to select and fit view. So when you select fit view in VisualCAD, it automatically fits the view to all of the geometries that are visible to you in the viewport. Now with this new enhancement, if you select a couple of geometries, like one or more geometries, and then select the fit view command, it'll automatically fit the view to only the objects that you've selected in here. As you can see here, I picked 2 of the objects. You could be selecting solids, surfaces, meshes, or even just curved geometries. So the objects that you select, and then when you select fit view, it automatically fits the view to what you select in here. And again, we've also introduced what's called undo and redo of view changes. So as you select undo, it automatically goes back to the views that you were in earlier, and automatically zooms in and zooms out based on whatever you had set the view changes to. So this feature is available in VisualCAD 2019, the ability to fit view to select objects. And you can also use the view changes in here. These are one of many enhancements that are available to you in VisualCAD 2019. So this automatically also applies to view changes as well.
One quick note, I just posted the PDF links for both what's new in VisualCAD CAM and what's new in RhinoCAD CAM in the chat window. So you should have access to that. Thank you, Uday.
Thank you. So, so these are a couple of enhancements that you're noticing here. There's also a new object snap that's been introduced in VisualCAD 2019. This would allow you to automatically snap to vertices of mesh geometry. So the example that you're seeing here is a mesh geometry, and we have a new snap called vertex snap. So when you enable the vertex snap, and let's say you wanted to analyze one of the corners of the mesh geometry here, so you can go to analyze and use vertex, and with the vertex snap active, you can actually identify the corner location of the vertex that you're trying to pick in here by enabling the vertex snap, and you can basically go over to the endpoint. So it automatically gives you the vertex of the triangle in here from a mesh model. So the vertex snap works with mesh geometry, so it could be importing STL or any other mesh files, and you can use the vertex snaps. There's also been changes that have been made into the near and end snaps, so those will automatically continue to work with your for solid surface geometry. So if you have a solid model that's created in here, or if you have a surface model, you can still use your near and end snap, and these will automatically be able to snap to the near points or the end points along a vertex, along the edge or the face edge of the model. So that's also an improvement where it's been improved to eliminate, speed up the performance of the snap objects.
Yeah, the big change there is the vertex snap will only work on mesh vertices. What was happening before was that the near snap was actually snapping to mesh edges also, and so if you had a large mesh, you saw quite a bit of a performance decrease. So what we have done is separated out the snaps. So most of the snaps, except for the vertex snaps, work only on 2D geometry, 2D and the surface boundary geometry. And so this should make things go easier and also help in the construction, 2D construction that most of you use our products for.
Thank you, Joe. We've also introduced how you can view the grid and the curves when you're working in shaded mode. So I'm going to give you an example for that and see how that can benefit you in viewing and modeling in VisualCAD. So typically, by default, the viewing of the grid and the curves will automatically be not visible when you have a model that's shaded. So for example, I have a curve on the bottom of this part, and you can see that the curve in the hidden areas by default aren't visible in here when it's shaded. So we have added a new option in VisualCAD, so you can go into Options, and then under the Display section, you will have an option called Disable Depth Testing for Grid. So when you select this and then pick Apply, you will now notice that the grid is completely visible even in the hidden areas or the shaded areas of the model. So you can enable this by just toggling the depth testing option under Options and Display. Likewise, we also have an option to display the curves. You can go ahead and select Disable Depth Testing, and when you pick Apply, it automatically displays the curves that are in the behind the shaded areas or hidden areas, you could call it. So now you can see the holes that are clearly visible and also the curve that follows the silhouette of this part geometry in here. Again, these options can be found under the display options in VisualCAD, and you can enable them by going down to depth testing. Now these are few of the enhancements that I'm demoing here today. You can view the complete list of enhancements by taking a look at the What's New document in here. A couple of enhancements I would like to point out here is better display resolution to support high resolution monitors, 4K monitors. In the earlier versions, those icons were appearing smaller, so it was very hard to see them. So now they're automatically being scaled up based on the resolution of your monitor. And there's been other enhancements for view changes. The file translators have been updated for DXF, DWG, the IGES, STEP, Parasolid, and SAT. So these have been updated with the latest translators. You can also edit rectangle directly by editing them, so you can view the entire list of enhancements for VisualCAD. Now, if you do have any questions, please feel free to post those questions in the questions panel, and then we will now move on to the enhancements in our CAM product. So one of the new enhancements in our CAM module is an introduction of a brand new module for mill turn. We have it called the mill turn module, and you can find this both in VisualCAD CAM and RhinoCAM 2019. And this module can be added on as an add-on to your existing mill or turn modules. And this module is currently in beta as it goes out in our 2019 product. Now, to demonstrate this, I'm going to go into RhinoCAM and load the mill turn module. So what I have here is a part that requires both turning operations on a 2-axis CNC lathe, and also would require some milling operations that would need to be performed. So I'm going to go into RhinoCAM and select mill turn. So this is a brand new module that you can find in RhinoCAM and VisualCAD CAM 2019. So when you select mill turn, this automatically displays the interface for the milling and the turning. So you can program turning operations under the program turn tab, and you can also program mill operations in here. And then you can program both of these operations and simulate and post-process them out to your machine tool. So the process of defining the part is very similar to for folks who have used your turn module. So you just go into the part, select the select turn part, and then just highlight the part geometry, and we could define the part for turning, and we would program a couple of operations in here. So I have a roughing and a finishing operation programmed in the turn module that would basically take the cylindrical blank that we have started out with and bring it down to the finished shape of the part geometry in here. So we're going through a turning process, roughing and turn finishing. Now once I'm through with the roughing and finishing operation in turning, I would go in from the turn module to the mill under program mill tab in the mill turn module, select the mill browser, and we can now create operations in here where we can introduce a new setup to orient the coordinate system for the milling process, and then generate toolpaths in here. So first created a profiling operation to face this area out in here. You can use the simulation to run a verification in here. So once I have this faced out, I'm going to go ahead and machine this cavity using a facing operation. So for an open pocket, we could use 2-axis and facing. Select the features. I'm going to just grab the surface edges from the model in here. Grab the tool, specify the cutting parameters, establish your cut levels, and then generate the toolpath. Now let's go ahead and run a verification for this by going into the Simulate tab. So we've programmed a facing operation to program this open pocket, and then I'm going to add a drill operation from the hole operation in here, hole machining and drilling. I could select the hole features, specify the tool for drilling, and then enter in the drill depth and generate. So you could program milling and turn operations in the mill turn module. So the turn tab under the machining browser of the mill turn module allows you to program all of the turning operations. You have turn roughing, finishing, groove finishing, fallout curve, threading, and parting off. You could also program holes axially along the axis of rotation in turning. In the mill module, you could program all of your 2.5 axis operations, 3 axis operations, and you have access to 4 axis and whole machining operations as well. So this is a brand new module that's being introduced in our 2019 version that would allow you to do mill-turn programming in RhinoCAM and VisualCAD CAM. Folks, again, if you do have any questions, please feel free to post those questions in the questions panel, and we'll try to get them answered for you. Thank you.
So this mill-turn module, we're releasing it as a beta since we still have some work left in the post-processor. Most of the toolpath algorithms have been done. We're just waiting for customers who have requested this product to be actually tested out on the field to make sure everything works in terms of post-processing and the different types of machines that we can handle. And once that is ready, we will announce that as a product in the 2019 version. And I estimate about three months time frame. So if you're interested in beta testing it, please send us email, and we'll add you to that list. And obviously, it will be licensed and it's priced separately, so you would need to have a separate license code for it. So please send us an email. We'd love to have you on the beta program. Thank you.
Thank you, Joe. So while we are on this particular mill-turn module, I also wanted to point out one of the enhancements that we've added to our turn module in version 2019. So the part that you're looking at here has milling features and turning features. So in our earlier versions, you had to have the part defined for our turn module without the mill features modeled into it. So now the turn module can automatically handle just the turn features and exclude the mill features when you define a part in turning. So as you go into RhinoCAM and turn, and you select part and go into select part for turning, and when you select these surfaces model, solid model, it'll automatically exclude the mill features when the part is defined. So when you define the part and when you take a look at the part definition, you will notice that the mill features are automatically excluded, so just making it easier for you to define the part and programming your toolpath so you don't have to go and recreate the model or delete some of the mill features to program the, just program the turn features. So this is also one of the enhancements in our turn module for version 2019.
So when Uday says the features or milling features are actually excluded, what he really means is we are actually taking the model and spinning it about the axis to create what's known as a spun solid, and then we slice that spun solid to get the profile for turning. So that gets rid of any protrusions or any sort of cavities in the part will be spun, and you will get a truly revolved part that can be turned. So that's how internally it works. Thank you.
Thank you, Joe. So folks, next we'll go ahead and take a look at the enhancements in our mill module. And before I forget, I want to point out that the turn module will now be included with mill module starting with the standard configuration. So if you have standard, expert, professional, or premium configurations, you will automatically get the turn module included starting with version 2019. If you are running the express configuration, you will have to upgrade to standard or one of the other configurations to be able to get the turn module. The turn does not come included with the express configuration, so it's only available starting with the standard and higher configurations in 2019. So folks, those of you who have a CNC lathe or a turning center and would like to use the turn module, you will have this available included in 2019 starting with the standard configuration. So the next thing we're going to cover is the enhancements to our mill module. So we'll start with the usability enhancements first. So I'm going to go into VisualCAD CAM, and I'm going to go ahead and load the mill module in here. Now, one of the enhancements that's been added here is the ability to specify your depth per cut, or we call it the cut depth, when you define your tools and then save them to your library. So you can specify the maximum depth per cut for each tool as you define the tools in here. So you can see that I have a 1/2 inch end mill. I have set the maximum cut depth as 150 thousandths, and then for the 3/8 end mill I've set it as 100 thousandths. So when you specify the cut depth in here, and as you program your machining operations, you will now notice that under your cut levels tab, as you specify a cut depth, you will see an option to automatically use that depth per cut in your cut levels tab in 2 and 3 axis operations. So I can select this little graphic image that you see here, and it'll automatically apply the depth per cut that you entered in as you define the tool, so you don't have to go back and re-type it in here. Then when you generate it, it'll apply that value that you put in for your depth per cut when you program toolpath. So this is available in 2-axis operations and also in 3-axis operations like roughing operations, and you can take advantage of this in version 2019. As part of the usability enhancements, we've also introduced checking for tool number conflicts when you post-process your machining operations. So if you have 2 or more tools that have been defined with the same tool number, when you post-process, the system will automatically notify you saying different tools with the same tool number have been found, and would you like to continue post-processing? So this will allow you to eliminate conflicts with the tool number before you post-process, since the system will automatically check that for you when you post-process. You could go back into your tool and verify the tool numbers. Here you'll notice that both the flat mill 1/2 inch and the 3/8 end mill have both been assigned with tool number as 1, so it identified a tool number conflict, so you can go back and update your tool number, fix that, and then repost it. So this will eliminate conflicts when you post-process your machining operations out to your CNC machine. So this is one of the many enhancements in version 2019, and you can find all of the enhancements in the What's New document for version 2019. We've also introduced better display for a higher resolution monitors. So similar to what we've done in VisualCAD, we've also implemented higher resolution display for which automatically scales up all of the icons in the VisualCAM interface. It also applies to RhinoCAM as well, so to basically make it easier to appear and read for higher resolution monitors. There's also several other improvements where loading and saving of tool libraries are now basically saved to the last saved folders rather than the last access folders. The next thing I'm going to point out here is the setup information and the toolpath information is now added to the title bar in the toolpath viewer or toolpath editor. So as you edit and go into your toolpath viewer editor, you will notice that the information about the machining operation, which used to be displayed at the bottom of the toolpath viewer, is now moved to the title bar, which gives you more room to display your CL file or the cutter location in here in the toolpath viewer. So it gives you more room to view this in here. And if you're programming setups to orient your coordinate system to program it from different orientations, now the setup will also display the information about your coordinate system. So if you have a rotate table setup or if you have a coordinate system setup, it'll automatically display the angles as well for rotation as you select setup and then go into your toolpath editor or the toolpath viewer. So 2 enhancements in here. One is the display of the machining operations info is now moved to the title bar in your toolpath viewer or toolpath editor, and the setup information is also now being displayed in the toolpath viewer or toolpath editor starting with version 2019. Again, folks, if you do have any questions at this point of time, please feel free to post these questions in your questions panel, and we'll be more than happy to answer them for you. The next thing we would like to cover is enhancements to our feature-based machining. Now, we've introduced a new type of feature which can be identified. These are called silhouette features in version 2019. Now, we could identify by default the features tab is located on the machining objects browser in version 2019. We also have an option to toggle this display of the features tab to have it appear on the machining operations browser if you like to. So you can just go into CAM preferences and features, and you can toggle this to display the features on the machining browser. When you do this, the features tab will now appear next to the program tab on your machining browser, or you could have it displayed the way it used to do it in versions, previous versions like 2018, where the Features tab can be displayed in the Machining Objects browser. So the Features tab can now be toggled and have it displayed to your preference on the Machining Operations browser, or it could be part of the Machining Objects browser. Now on this particular part, I'm going to perform automatic feature detection. For those of you who aren't familiar with our feature-based feature detection and feature machining, we can identify several different types of feature types on prismatic parts like these. The brand new feature we've introduced is called a silhouette feature, which will help you be able to program either a roughing operation in 2-axis or create a profile operation in here. So I've created a feature detection on this particular part, and you'll see that there's different feature types that have been identified. So the new feature type is the silhouette feature. In addition to silhouette feature, we could identify planar features, prismatic pocket features in here, the pockets, hole features, chamfer features, open slots. We have planar faces, hole features, and if you have parts that have multiple orientations, we can identify features from multiple orientations as well. So I'm going to generate a toolpath for this using automatic feature machining. Before I do that, I'm just going to go ahead and clear out these operations that I had programmed earlier in here. And I'm going to go into automatic feature machining and generate a toolpath for this in version 2019. Again, folks, if you do have any questions at this point of time, please feel free to post those questions in the questions panel, and we'll be more than happy to answer them for you as we go through this webinar in here today. So the feature-based machining allows you to identify different feature types, and we'll select the orientation in here and then select automatic feature machining, and you'll notice that it automatically generates toolpaths for each of the features on the model. So we have features toolpath generated for the facing operation in here, pocketing for the closed pockets, prismatic pockets, profiling, profiling the silhouette using the silhouette feature, slot machining, hole features can be programmed using drill operations, and then the chamfer features in here. So I'm going to run a simulation of this. Right-click, select Simulate. And you'll notice that the toolpath is generated for each of these features. So within just a couple of button clicks, one button click to identify the features and the next button click to generate toolpaths for these features, so you can automatically generate toolpaths using feature detection and machining. Now, the What's New document also shows the different types of features we currently can identify. And we have hole features, prismatic pockets for closed pockets. We can identify open pockets, boss features, 3-axis pocket features on cavity molds that you have, could have sculpted bottoms or sculpted floor surfaces, slot features, open slots, T-slots, V-slots, 3-axis open pockets, planar faces. If you had fillets and chamfers on a prismatic part, we can identify fillet and chamfer features, a step prismatic pocket, and now in 2019 we also have a silhouette feature that can be identified. Again, folks, if you do have questions about feature detection and machining, please do post those questions in the questions panel, and we'll try to get them answered for you. Now, moving on to the next enhancement, there's a brand new toolpath method that's been introduced in VisualCAM and RhinoCAM 2019. This can be used for programming drag knives, and this is available starting with the standard configuration of our product. Now, to demonstrate this, I'm going to go into our RhinoCAM product in here, and we'll go over that. So the the drag knife toolpath method is available in standard configurations and above. So if you're running standard, expert, professional, or premium, you will have access to this. And you can find this under the 2-axis methods. You'll find 2-axis and a drag knife cutting operation in here. You can specify your part region, similar to how you've done in profiling and engraving operation in here, and then select your tool. You can also edit the tool definition in here to specify the parameters for the knife, or you can specify the left angle, right angle, the blade parameters in here, and establish your cutting parameters, where you can specify the total depth your swivel depth, and the corner limiting angle for knife cutting operations in here. So what I've done here is programmed a drag knife cutting operation, and you can see that based on the corner angle that's specified in here, corner limit angle, it automatically does a retract and swivel based on the limit angle that's put in here. Now when you run a verification in here, so let's go ahead and run a simulation, and you'll see the knife being automatically oriented. As it's cutting, it automatically swivels to change the orientation based on the corner that you put in, angle that you specify.
So this method can be used for machining or cutting vinyl or sheet metal or things of that sort. I don't know about sheet metal, but soft material like maybe wood as well, thin sheets of wood. And it is a drag knife method, which means at the corners you have to have some sort of mechanism apart from actually the spindle to orient the knife in the cutting direction. So the spindle will be locked on the machine tool, and then you'll have to have some sort of arrangement for you to actually orient the cutter as the cutter comes to a corner. What we allow is when we retract back, the tool retracts back to a swivel height, and then we put in an arc motion that will allow the mechanism that's attached to the tool to actually orient the cutter in the right direction. There's a very commonly used drag knife called Donek, and you might be familiar with that. There's a lot of information on the Donek website, and that'll give you more information about how we handle that type of knives. Thank you.
Thank you, Joe. Folks, the next thing we will talk about is some of the other nicer enhancements as well that we have in version 2019 for VisualCAD CAM and RhinoCAM. And this is going to be the options how we can do cornering actions that can be applied for your profiling toolpaths. And this is again available starting with the standard configuration in both RhinoCAM and VisualCAD CAM 2019. So I've generated toolpaths for several of these profiles that you're seeing here on my screen. And as part of the cornering actions, you'll find there's a new tab in profiling operation that's called cornering parameters. And you can specify the cornering actions for both external corners and internal corners in here. So for the external corners, the default option is just round, where basically it rolls over as as the toolpath offsets and follows around the geometry. You now have the option to specify a sharp corner, so it extends past to find the intersection to result in a sharp corner rather than creating like a fillet as the toolpath rolls over. Or you can do a sharp limited or a loop, where you can specify the loop radius, and you can specify the min and the max angles in here for the extended corner filters. And for the internal, the sharp is the default option. Now you have the option to either do a dog bone or a T-bone option. And I'm going to go through this on these examples in here so you can actually see it as it simulates these toolpaths. So this example over here, the first one I'm demonstrating here is the loop option in here, and you can specify the loop radius. So on this particular operation, I've set the loop radius to 1/4 inch, and you can see how nicely it loops as it goes around the corners. So when you run a simulation here, you will see it loops around the corners. And again, this feature is available in profiling operations right from our standard configurations. If you have standard, expert, professional, or premium, you'll have access to these. So this is an example for sharp. So automatically it creates the sharp corners instead of the round, which is the default option. There's sharp and then sharp limited. So in this example, I'm demonstrating the sharp, and on the part on the right here, I'm going to use sharp limited, and you'll notice that the cornering parameters have set the overshoot length to just 0.4. So in this particular case, you're only noticing the sharp being applied on these areas, and it's excluded here because it's past 0.4 inches in here for the cornering limit. So you're not going to get a a sharp corner in here unless you go back and change this cornering parameter to a larger value in here and then generate it for the overshoot length.
So the idea here is if you have very acute corners, you don't want the toolpath to extend way beyond the corners. So some of our users have asked us to limit that, and that's why we actually extend a little bit based on your input parameter, and then we round the corner after that.
So this is the cornering with the sharp limited. And now for the insides, we have two options. The default is sharp, and then the other options are either doing a dog bone or a T-bone. So as you can see here, it extends past to basically, if you have an inlay or a part that needs to fit right into it and need to result in a sharp corner in here, if you leave it as just sharp, you wouldn't be able to accomplish this for the inside. So you will have to go ahead and change the you'd have to go back and clear material in here, so you can choose the option in the cornering parameters to either do a dog bone or a T-bone, depending on the type of cornering option that you would like to apply. Now here's an example for the T-bone cornering option for the inside corners. So these are the different types of cornering options that you can apply for both inside and outside. And again, folks, all of this information can also be found in the What's New document. And as I'm going through the What's New document, you'll find these right in here as well. The next thing we'll cover here is how we can do clustering in both VisualCAD CAM and RhinoCAM. And clustering is useful when you are, have nested parts or parts that require for the inside areas to be machined out first before you cut the outside. So, the parts are intact or stay within the sheet that you're cutting it from. So in two-axis profiling, you'll find this under the sorting tab, where you have an option to perform clustering. Now by default this is not checked, so when you have multiple geometries like these and you perform a simulation, it basically follows the order in which you have the geometry selected, or if you had applied a sorting sequence in here. Now in the option to do clustering, you can choose whether you want to do the inside out, selecting the cut order. If you pick inside out, it'll do the insides first before it profiles or cuts the outside. So you can select the perform clustering option and choose the cut order in here. So in this particular example, I'm going to pick inside out and generate the toolpath. You will now notice that it cuts the inside first before the outside is cut for the same part. So this option is called perform clustering, and it's available in profiling operations starting in version 2019. Folks, again, if you do have any questions, please feel free to post those questions in the questions panel, and we'll do our best to answer them for you.
Well, there was a question about high-speed machining. They wanted to see high-speed machining, so if you have time at the end of the webinar, if you can run through that very quickly, that'll be good.
Absolutely, we'll do that. So the next thing we're going to cover is enhancements to facing operation in 2.5 axis methods, and this is also available in all of our configurations in our mill module. So to demonstrate this, I'm going to go into one of these examples in here in RhinoCAM. And you'll notice that in our previous versions, we had to select machining regions for creating a facing operation. Now in version 2019, as you go and create a 2-axis and facing operation in here, you do not have to pick a machining region, and the system will automatically take into account the extents of your stock geometry. So the stock extents is automatically taken into account when you generate a facing operation. So the silhouette of the stock is automatically accounted for when you create a facing operation, so you don't have to create additional curve or sketch geometries in the CAD and select that as your machining region as you program a facing operation in here. So in this particular example, you're seeing that there is no part region selected, so the system will automatically take the silhouette extents of the stock geometry into account for the facing operation. I'm going to run a verification of this in here. Now the next thing we're going to talk about is the enhancements to pocketing operation, and in this particular example I'm also going to cover the high-speed cut pattern or the high-speed pocketing toolpath. So the high-speed cut pattern is available in two-axis roughing under the cavity cut pattern options. It is also available in two-axis pocketing, slot machining, and also three-axis roughing operation. So under two-axis pocketing, in the cut parameters, you'll find high-speed cut pattern as one of the options in here. You can select the high-speed cut pattern. And one of the enhancements that's gone into version 2019 is when you pick a start point for the pocketing operation, it does a tricaudal or a high-speed motion as it goes from the start point down to the first cut level. So it automatically creates this high-speed or a tricaudal cut pattern as opposed to just a linear motion as it's supposed to do in the previous versions of the for CAM product. So you'll now notice that when you run when you generate the toolpath and run a simulation, it creates the tricaudal cut pattern, tricaudal motion in here from the start point that you define to the first cut area, start of the first cut location. So the high-speed cut pattern is available in our mill module starting with the standard configuration of our product. Now, just to let you know that RhinoCAM 2019 will be available both in Rhinoceros 5 64-bit and also in Rhino 6 64-bit. So folks, those of you who are running Rhino 5 or 6, you will be able to run RhinoCAM 2019 in either of these versions of Rhino. I hope I answered your question about the high-speed cut pattern. The next thing we're going to take a look at here is the enhancements to our simulation for collisions. And to demonstrate this, I'm going to go through an example with a profiling operation on this particular model. So I've programmed a two-axis profiling operation in here, and I'm going to run a simulation for it. And you will now notice that if there's a collision of the holder or the shank during simulation, you'll be automatically prompted with this warning to notify that either the shank is colliding with the stock or the holder, and as you select yes, it automatically steps to the simulation to the next collision point, or you can say do not show this again and run through this. So you'll notice that once the simulation is done, you'll see the collision areas for the shank and the holder. They're marked in red in the simulation. And you'll also notice the machining operation is automatically flagged dirty. And as you go into your toolpath, you will be able to identify the toolpath motions that result in the collision. So if you go into the go-to motions, you'll see the collisions being marked in the toolpath viewer and toolpath editor as well. It automatically identifies these collision areas in the toolpath viewer. So you can take appropriate action to either change the tool length or the flute length and update your toolpaths before post-processing it out to your machine. So this is also one of the enhancements in the simulation that has gone into version 2019. And again, this information can be found in the What's New document that's been made available to you as well. So the next enhancements we're going to take a look at is the improvements that are made into three-axis toolpath methods. And to cover this, I'm going to go into an example in VisualCAD CAM. So in the three-axis operations where we had clear flats machining, we made an improvement to clear flats machining to handle geometries that have fillets and chamfers much better. In the previous versions, you may have noticed in some cases you may have identified some a gouge or collision in the model in here. You can see these areas that are marked in red shows collisions, gouges here where due to the fillet on the part geometry, the clear flats wasn't able to handle it very well on certain cases. Now these have been addressed well in version 2019. So I'm going to suppress this operation that was generated in 2018. I'll go ahead and run the same in version 2019. I'm going to run a simulation of this, and you will now notice that when I perform a comparison of the part to stock, those issues have been automatically addressed and resolved when you have fillet and chamfers in the model and you perform a clear flat operation on those areas. Again, the clear flat option, you can find it in the 3-axis methods, and it's available in all our configurations of the mill module. Now the next thing I'm going to cover is the improvements to parallel finishing operation that has been introduced in version 2019, and I'm going to use an example in RhinoCAM to demonstrate that. And this would be under cut connections. So in parallel finishing, you have the option to specify cut connections under the entry and exit tab. And as you choose linear and add loops to it, now these loops can automatically fit arcs to these toolpaths. So you can see the loops are much nicer, smoother, so it'll reduce the number of lines of code and makes the transition much smoother when you add loops and fit arcs to these toolpaths. So these improvements can also be found in our mill module in both RhinoCAM and VisualCAM 2019. And again, folks, you can find all of this information in the What's New document as well, in both RhinoCAM and VisualCAM 2019. The next thing we'll take a look at here is the enhancements to our 3-axis pencil tracing operation. And the pencil tracing operation is available in our Pro and Premium configurations of our mill module. So in pencil tracing, we are now able to handle computation at a much faster rate compared to our previous versions. So there's a new parameter that's been introduced which is called the minimum cut length in version 2019, and to generate toolpaths for parts like these complex areas that you have on the model, it does it in a much faster time. It's almost like 4 to 5 times faster than what you noticed in the previous versions in here. And you can see the pencil trace toolpath that's generated on this particular model. So these are some of the 3-axis enhancements that I'm showing it to you in the webinar. You can read the entire list of enhancements in the What's New document. The next enhancements I'm going to cover here is the enhancements to skim clearance in both RhinoCAM and VisualCAD CAM. And to demonstrate this, I'm going to go ahead and take an example in RhinoCAM, and we'll show you how the skim clearance enhancement works in 2019. Now here I have an example of a prismatic part where I've programmed some pocketing and profiling operations. I'm going to run a simulation of this in the profiling, and you notice that in the pocketing operation, this was generated in previous version of RhinoCAM. You'll see that when you generate a toolpath with the skim clearance, under some circumstances, the skim clearance was not clearing the entire part geometry in the previous version. So this would have ended up cutting through the part geometry in here, or the stock that you can see right there. Now in version 2019, by defining your skim clearance under the clearance plane tab for cut transfer method, generating the toolpath, it'll automatically clear the max height of the part geometry as it transfers from one cut area to the next. So this is an improvement and enhancement to version 2019 for skim clearance, and again available in the mill module in all our product configurations.
So the actual change here is since the 2.5-axis modules only look at curve geometry, the skim clearance previously in the 2018 and prior releases was only looking at curve geometry to compute the clearance, the skim clearance height. But now what we have done in 2019 is actually, if you do have 3D geometry in the part, we actually look at the 3D geometry also to compute the skim clearance. So we find a lot of our users are now bringing in more and more 3D geometry and not just purely 2D. So this enhancement was a request from quite a few of your users. So that should be a good one for you.
Thank you. So while we are looking at this example, one of the other enhancements also would like to point out is the ability to automatically set the max spindle speed and the max feed rate based on what is defined in your post processor. So as you go into load from file in your tool definition, now the maximum spindle speed and the maximum cut feed rate is automatically pulled in from your post processor depending on what post processor you select and what you define as your max spindle speed and max feed rate. These values in here that you're seeing for the max limits for computation are automatically read from your post processor. So if your post was set to 20,000 RPM for spindle and 500 inches per minute, that information will automatically be read into the load feeds and feeds from table. And this is available both in your tool definition and also in the machining operations. As you go into feeds and speeds tab and select load from file, the max spindle speed and the cut feed rate is automatically read from the post processor that you select. So if you change your post and go back into the dialog and select load from file, it'll automatically read the feeds and speeds that you had defined in the post processor. This is also one of many enhancements that have gone into version 2019. Again, folks, if you do have any questions at this point of time, please feel free to post those questions in the questions panel, and we'll be more than happy to answer them for you. The next thing I'm going to cover here is an enhancements that's gone into 5-axis. We've now added the ability to support machines, head-head configuration machines that have mutating heads. So when you select the machine configuration as head-head, you now also have the ability to set the tilt angle for rotary axis for machines that have a nutating head. So I'm going to show you an example or a picture of what a nutating head looks like for those of you who are not very familiar with a nutating head, in a 5-axis machine setup. So what I have here is a picture of just a head configuration. The nutating head is where the secondary axis is not orthogonal to the primary axis. So you can see that the secondary axis, rotation axis of the secondary is at about 45 or 50 degrees, so depending on how the head is set up on the machine tool. So this type of head are considered as a nutating head, and now our premium configuration will be able to support machining toolpath generation for nutating heads for simultaneous 5-axis programming. And if you're using the Pro configuration, you can program for nutating heads for index 5-axis operations. So the Pro supports index 5-axis, Premium supports simultaneous 5-axis, and now for machines with head-to-head configuration, we will be able to also support nutating heads as well. Now, in addition to being able to support nutating heads, we've added enhancements to our post processor to be able to support for additional variables to be able to output coordinates values in the world coordinate system for posting when you're post processing in local coordinates for 5-axis operations. So there are several additional variables that are being introduced in the post processor, and this would be helpful when you program 5-axis toolpaths using VisualCAM and RhinoCAM in version 2019. And if you have questions about these variables, you're welcome to drop us an email, and we'll be more than happy to get those questions answered for you. We can also define or select user-defined tools in drilling operations, which you weren't able to do in the previous versions. So version 2019 allows you to define user-defined tools. We've already covered the enhancements to simulation. We've also added additional machine tool models in version 2019, and you can find these machine tool models in the list of machine tools as you go into load from file. When you go into machine setup, you can go into load from file, and you'll find the additional machine tool models. Now, the load from file option for performing machine tool simulation is available in starting with the expert and higher configurations in version for mill modules. If you have expert, professional, or premium, you can use load from file. Now, last but not the least, I'm going to cover our enhancements to our nesting module in here. And I'm going to go through an example and give you a quick demo of our nesting module as well. Again, folks, at this point of time, if you do have any questions, please feel free to post those questions in the questions panel, and we'll do our best to answer them for you. Now, nesting module is available in RhinoCAM 2019, and in this version, we will now be able to also perform nesting of solid models. So you can actually nest solid panels or solid geometries as you nest them into your sheet. And for those of you who are not familiar with our nesting module, I'm going to give you a quick overview of this. Now, before I get into nesting, I want to show you how easily you can take a assembled cabinet design model that you may have modeled in any of your CAD applications. You could bring it in from SketchUp or any other system. We have a utility called Explode Cabinet Design, and this will allow you to basically explode the geometries, meaning automatically flatten them out and place them on your XY plane, where you can use these parameters in here to establish how you want to explode just the 3D model or the 2D curves. You can explode them, and this will automatically place these models on your XY plane or parallel to XY plane. It automatically flattens them out, so you don't have to go through the process of decomposing them, each of them individually. Now, once you have these panels exploded, you would want to go ahead and nest them. In our previous versions, we were only able to nest 2D geometries. Now, starting with version 2019, you will be able to nest even 3D models in here, and I'm going to give you an example of that in just a moment. So I'm going to switch from the RhinoCAM's mill module into the nest module. Now, the nesting is available both in RhinoCAM and also in VisualCAD CAM, and it's included with your mill module. So if you have any of our mill configurations, you'll automatically get the nest module. So we have two types of nesting, true shape and rectangular nesting. The next step is to select the sheets to nest. Now, in version 2019, in addition to being able to select the curves that you've drawn to represent the sheet, you can actually define your sheets, where you can specify the length and width of the sheet, or length and height of the sheet, and you can also specify your sheet thickness in here. And you can add the sheet, and you can also create additional sheets as needed. So you can see here that you can either select the sheet that you already drawn in the CAD, or you can define a sheet by just specifying the two corners of the sheet. You can specify the nesting direction and also the grain direction for your nesting. Now, in the next step, we can select the parts to be nested. You can still select curves as you did in previous versions. In 2019, you can also select solids or surfaces or mesh geometries to be nested. So I'm just going to go ahead and select all of these panels that we created using Explode Cabinet Design. And once I have these selected, I can go ahead and specify the count for each of these parts. I can set the priority for nesting, orientation, and the grain direction, and orientation step angle. Under nesting parameters, you can specify the distance between part to part, distance between part to sheet, and I'm going to execute the nest, and we'll now preview the nest. So you'll notice that the execute and a preview nest, they've been separated to two tabs. The preview nest has been put out on a separate tab in here. And you'll see that since I had the sheet count only set to 1, there were several parts that were unnested. So in 2019, you'll also be able to identify the parts that were not nested into the sheet. So as I selected from the list here, it highlights the corresponding part that were not nested into the sheet. So all of these parts were unable to be fit into one sheet, so they were not nested. So I can go back and I can select estimate number of sheets. So it'll estimate the number of sheets required to nest all of these parts into a sheet. So it says I need a total of 2 sheets, update the sheet count, execute the nest, and I can preview the nest. So right now the results are stacked on top of one another. I can also have them placed along X or along Y and specify a spacing for those. So I'm going to go back and execute the nest again. We'll preview the nest, and now I'm going to do a commit nest in here, and this automatically nests those solid geometries into the sheet. And folks, if you do have any questions, please feel free to post those questions in the questions panel, and we'll do our best to answer them for you. So you'll now notice that there is 2 sheets, and each of those parts are fully nested into the sheets. And each of the sheets are automatically placed on separate layers, and as you select the layers, it automatically selects all the objects on those layers. So with this, I would like to hand this back to Joe. This gives you a summary of all the new features that we've introduced in version 2019, and we're open for any questions that you may have at this point of time.
Thank you, Uday. That was a very nice introduction to what's new. As Uday mentioned, please check out the PDF documents that give you in more detail what has gone in. And I also want to point out that we are running a pre-release sale right now. So Uday, if you want to go to the e-store, this sale is only applicable in North America. If you're outside of North America, please talk to your local reseller for the products. They might be running their own specials, but here in North America, we are running a release special. And go to our website or go to our e-store, and you'll see we are running a really good special at this point. Sorry to bring in a little bit of a sales pitch here, but we are, as Uday mentioned, the new products 2019, any of the configurations aside from the express mill configurations will be getting the turn module free of cost, and we are also running a 20% discount for new product sales, and also 10 to 15% on the upgrades. So you can read all about it in our website. And I think we are pretty excited about this release because I think we have added a lot of value in the product, and it's a complete CAM product right now, including nest, arc, turn, and mill. So we are quite excited to be offering this product out to you. Just a few questions I wanted to take before we close out. We're running a little bit over time. Somebody asked us, what is the release date? The release date is we are slating December 10th. We're hoping we'll release it then. We might slip by a week or so, but definitely early part of December we should have that out. And one more, any price changes from the previous release? No, not really. There are no pricing changes, but what we've added, as I mentioned, we've added more value for the same price. So people who are on older versions of the product really ought to take a look at the new products. And as I mentioned, there's a lot of value that's in it. So, and Uday, I think we're just about ready to wrap it up. So thank you all for taking time off a busy schedule and attending this webinar. If you have any questions, please feel free to email us, and we'll be more than happy to answer them. And as I mentioned before, this recording will be available and sent to all those you've registered. Thank you very much, and take care.